For today's exercise, we'll have you either install Docker Desktop or Postgres. We'll use Docker Desktop for the exercise. However, if you don't have access to that, then go ahead and install Postgres directly. You can use the GitHub repository to walk through how to install that. During the exercise, we're going to create a Postgres server, create a Postgres database, and then insert, update, read, and delete data. We'll start today by pulling down an image of Postgres and running that. We'll pull that from Docker Hub, so we can do that with docker pull Postgres 11. I should already have that pulled down, so mine's pretty quick. We're using version 11 because it's the most commonly supported in cloud platforms currently, so it might have more compatibility with other exercises you'll see. Next, let's run the Postgres image. Do that with docker run detached. Remove it once we're stopping it. We're gonna port forward. 5432 is the standard port for Postgres, so we're just gonna forward that. Then we have to pass a couple of environment variables for what would be a username and password. And use something really secure, like so Postgres password is one of them. We're gonna set that to Docker. And then the other one is Postgres user. I mean, nobody's going to guess this. It's going to be Postgres. And then Postgres version 11 is the image we're going to run. That'll fire off an image. Awesome. Next, we need to run an image for something called pgadmin. This is a tool that's going to be able to let us interact with Postgres. So let's pull down that image. That's a docker pull dpage/pgadmin for version 5. And then we're going to run that. Is docker run. Port 80 is the one that usually works on, but I don't want to throw 80 as a bound port in case of collisions. So I'm going to use 81 locally. And then similarly, there's some big security stuff here where we will pass some environment variables for an email instead of a username. And a password. We're gonna really be secure on that. Nobody's gonna be able to guess these things. And then the next one is pgadmin default password. And that one's gonna be Docker, because why wouldn't it be Docker? We're gonna do that detached, and then we're gonna pass the image, which is again dpage pgadmin for version 5. Now, having done that, we should be able to open a browser to the localhost 81 and connect to this Postgres instance. That's the next thing to do. I've navigated to localhost 81 in a browser, in this case, Edge. And now I see my pgadmin. This is a sort of a server browser tool for Postgres. We're going to log in with the credentials we specified when we started the Docker container. So that's the user at domain.com and Docker for the password. Now that we're in this screen, we have to add the server. So that's the Postgres server that we started in the other image, the first image we started. We can do that via right-click, create server. This is the browser window here we're doing that in. Give it a name, Docker Postgres. Connection. I'll say this name doesn't matter, it's just a label. But for connection, because we're hosting through Docker on the same system, we'll do host.docker.internal. That's specifying the Docker network. We then can fill out the rest of this. We used, I believe, the default port. The username was Postgres. And the password was Docker. We click save. We should have our Docker Postgres instance. And there we are. Let's create a database. So we have the default one that comes with Postgres, but I think we want our own thing. So let's right-click Databases, Create Database. And over here, we're going to have to name it. It's a lot of responsibility. I'll take it on. Non-zero database. Might not be best practice to put database in your database name, but for the purpose of today's exercise, it's good to have some brevity. Go ahead and save that. And we now have a database. And if we right-click this database at any point in pgadmin, we can say create script. And this actually shows the script that would go into creating this database if you wanted to automate this process, which inevitably we probably will want that. If we right-click the database and then go to Query Tool, we can start doing some interesting things in here. We can actually create tables or manipulate data. So let's do that next. In the Query Editor, you can also look at query history to see what you've already sent, but in the Query Editor tab of this, we're going to create an extension, and then we can add to that if not exists. That just says if it's already in place, don't try to throw errors or complain. But UUID-OSSP, this is an extension built in to allow me to get a unique identifier. And then the next thing we'll want to do is, making mistakes already, need that semicolon. The next thing we want to do is create a table. So we're going to create a table, again, if it doesn't exist already. And it'll be our non-zero table. Just once again, using that concise terminology, you know immediately what it is. Again, not best practice to include table. It's the joke I'm going for here. We want to put within that some parentheses with defining what columns would be in that table. So again, we're making rows and columns. Columns are going to be the defining separators in our schema. So we want an ID. This is going to be a unique identifier, UUID. It's going to be our primary key. It's going to be defaulted if it's not provided. And we'll default it through the generate v4 function that comes along with the extension that we called in. Then next, want everything on the same tab there. We'll have name, which will be some text. It can't be null. We'll have age, that'll be an integer, and that can't be null either. Then we'll have an address, that'll be like some characters, about 50 in length, why not? And at the end of this, we need that semicolon. If we run this, we should have a table in our database. We can do that via the F5, or we just click execute up here. You'll note it says that it returned successfully. It created a table. That's a good sign. We review. We have our database. And within that, we have a table. So the next thing we can do is manipulate some data. Let's start by verifying there's nothing in the table. We can clear out this, or we can keep it there and just highlight what we want to run. Let's just highlight for now. We'll do a select star from, and we know the table's name is non-zero table, semicolon. If we highlight just the text we want to run, and then execute, we see that it just ran the select statement. It didn't try to create it again. And there's nothing in our table. So let's add some. We can do an insert into non-zero table. We're going to pass in a name, age, and an address. We'll pass in the values. Maybe Joe. Joe's about 30. And he lives at home. And then semicolon. I'm going to tab that just because I like that. And if we run that, select and run that, it's running successfully. That's good. We go back up to the select and highlight that, or type select star again and run that. We see that there's now an entry for Joe. And it came with a UUID. Came with that ID that was generated by default using this generate method. That's good. If we wanted to update that, we would have to do an update script. So we can do update non-zero table. We're going to set age equal to 31. Joe's growing up. He's growing up so fast. And we're going to do that where ID is equal to, and we can just copy this. If I do Control C, don't need those extra quotations. Our ID is equal to that UUID that we have. We run this. Who's forgetting semicolons? We run that, and then we select again. We see that Joe's now 31. That's good. And finally, the other main activity that you would do is a delete. So let's delete from non-zero table. And then we'll add the condition where ID is equal to, we know for a fact that's what the ID should be. ID is equal to that. And we should expect that that will delete Joe, at least his data form. And it's no longer there. If you're not familiar with SQL at all, which has been around for quite a while as an interface, as a contract, if you're not familiar with it, this might not be intuitive, but you can extract all of this to a file, a SQL file, .sql file. And that helps a lot for automation. For instance, if I right-click, create that script again, grab this database script, go back over here, and plop it at the top, then we've got this notion of how to automate the entirety of what we accomplished today. And we could, for instance, save that to a file and pass it in to the Docker container when we spin it up. That Docker image, the Postgres Docker image, allows you to pass in SQL files and it'll run them by default. So it's common when you're creating a database with some schema, tables, what have you inside of it, to capture everything that you accomplished into a SQL script at the end. Now, typically you don't need to do this whole insert, update, delete, cleanup process within that, but you might have sample data or staging data depending on your environment that you want to store in there. So there is a use case for doing database, table, and inserts of data. It's worth calling out. For the purpose of this exercise, I will be extracting the SQL that we've run today into a .sql that I'll put into the GitHub along with the README. In today's exercise, we created a Postgres server, then we created a Postgres database. Within that database, we created a Postgres table, and against that table, we inserted, updated, read, and deleted data. If you have additional time today, you might check out the links in the description below for PostgreSQL commands or its about page. If you are particularly interested in the topic of data storage, it's worth noting that Postgres is a simple and cheap data storage technology that makes it a great choice for initial learning ventures into current data storage practices. But there's quite a few other technologies you can choose from. And if you're intrigued, then you might feel free to check out the alternatives, such as MySQL or Redis or MongoDB. If you don't have additional time today, congrats on your non-zero day.